Hello, everybody. I am Marco Orellana. I am CIDAI's manager. As you know, CIDAI is a key element for the Catalonia AI strategy. Our mission is to demonstrate the advantage to speed up the adoption of innovative data exploitation artificial intelligence technologies. We are working on several tasks to increase the adoption of this technology in the territory. One of them is this masterclass. Before to introduce our speaker, if you work in an SME and you have ideas to develop some proof of concept with AI technology, please visit the project EU Hub for Data. Here you will find some interesting financing opportunities. Today, thanks to the Barcelona Supercomputing Center, a core partner of CIDAI, our speaker will be Cesare Cugnasco. He's CEO of Cubist, PhD in computer architecture, and researcher at BCC. In this masterclass, our speaker will outline the major trends in data ecosystem, explaining the emerging architecture, the key players, and the current and future challenge. Remember, you can ask all the questions that you have. We will have 10 minutes to discuss your doubt at the middle and at the end of the session. Please, Cesare, the floor is yours.
Thank you, Marco, for the introduction and for inviting me for the opportunity to make this presentation. Just let me share the screen. I hope you can see my screen now. So yeah, thank you for this opportunity to make this presentation. I think when you approached me to these topics, I was trying to get a topic that would be also interesting for me to get into the topic, to study a little bit more, and that it was, I think, a very great opportunity to have a brief overview of all these big topic with a lot of players and a lot of technology. I think it's really interesting to see how the evolution, so what has been the data infrastructure in the past, in the present, and the future, and I will try to do my best to give an outline of all the different technology and kind of to give it the key idea. On that said, of course, I will have to do some approximation and summarize many things. So please be free to make a question anytime. So if you want to get more information or you want to get into some details. So first, before to start, just a few words about my background. I am, as I like to say sometimes, I'm a computer engineer that's also moved a little bit to the dark side of business. I've been working 10 years for the last 10 years in big data in specific and how to use big data technology for science. I've been working on a project like a human brain project, how to store the data of the brain and understand how make easier to data scientists to explore MRI images of the brain. It is also work on different industrial projects and exploring how different storage technology can accelerate data intensive computing. I think this also be interesting because according to this working in this project is also what we found out there was a better way to store data, and this led to the creation of a patent. There's also is what led to the creation of a spin-off from the Barcelona Computing Center 2 years ago, which is Cubist Analytic, where I currently work as a CEO, and I am one of the founders. And saying that, especially to understand that we have a skin in the game in this big data ecosystem, especially we work on making this data lakehouse architecture that we talk to making it more effective. And nevertheless, I will try to be more objective in describing all the different trends. But it was fair to say that we have our bets in this game. So we have some opinion in what we think is going to be the leading architecture in the future. On the set, I try to divide this presentation in 3 stages, in 3 steps. First, a little bit an historical view to understand why and how we got it to the current stage of technology. Then we will try to discuss the current stack and exactly what is the state of the art nowadays. And I think this is also interesting because in talking to more than 100 different companies and try to align differences and things that we've seen working in many different companies and how they are, there's not like a unique solution, but there are some common patterns coming outside, trying to highlight some new trends in the technology stacks that we are seeing they're coming out, And last but not least, I will try to talk a little bit of what are still the challenge ahead in the data ecosystem, not only on the technology point of view, but also in the way company organize and the society organize to make sure that they can take benefits of the data. Preparing this presentation, I had to go through hundreds of web pages and websites, but I think those the ones that I put here in these pages are the ones that I use the most. I think it's also too interesting to see the different timings. So I started to actually to take back some of the data warehouse book that was written 20 years ago, and I was using the university to understand what were the problem 20 years ago, and the main ideas. I lean a lot on the reports that's been developed from BC. I think is to understand the current stage of data. It's really interesting to see this kind of report that they make. I think they have a very good way to make a cut, but also to be fair, they are BC, so they have also skin in game, so they probably be biased in one direction or the other. Above all, I think that's the report from Anders Horowitz on the future and emerging modern data infrastructure, really interesting, and also then the data landscape panel from Matt Turk. I think they're really interesting. And for the future thing that I've been leaning on two main documents. So there is this data mesh provided by Zamak. That I think is a very interesting book to see what are current limitations and where we can going, but also to work on the design principle for data space, international data space, to understand what also Europe wants to go and which are the political needs and push in this area. This is just to give a view of what are my sources, and I will also put the links when I can, but this in general to understand where all this information comes from. So to start, I will get here. I think this image is really interesting to see how complex and how confusing can be the current big data stage and all the technology that's are playing a task and a role in the modern AI and machine learning MBI ecosystem. Not only is incredible the number of players there inside there, this I don't think is so much a problem. I think it's interesting to see how many different categories and how many different tools needs to play together to make an effective solution. And I think this is really a sign of the time. How did we got it there? How we arrived to such a fragmented and complex environment? I would like to take an historical point of view, and let's go back 20, 30 years. I think that's when we start to get some data and start to work on analytics. It was pretty traditional to have one single database that will work both on operational workloads and analytical workloads. So you will have a Postgres database, for example, or some other mainframe that will serve both operational workload, and it will also allows to the manager of a company to understand what it was going on. So typical example, a bank to understand a system that's manage all transaction, but also to understand which are the current rate of transaction that are going on. Of course, this approach had some limitation, namely the point that the single machine capacity was limited, and all the analytic workload was also impacting the operational workload. So we had two main problems. One is the efficiency of the system, so the machine could not keep up with these different workloads, and they were not optimized for none of them. For problem of consistency, so if you change something operational, and also you have to keep an analytical workload consistent, there was some limitation in how they exclude themselves. And there was also different point of the goals on how to organize data. So I think that's the big change we had. And again, we're talking about more or less 20, 30 years ago, is the emergence of this data warehouse architecture, which basically start to have the first, let's say, split in the data ecosystem to divide the needs into the operational workloads and one analytic system that will serve the needs for creative reports, spreadsheets, and SQL. And to connect the two different things, the operational and the analytical system, they will have some middleware that will do this extraction of the data from your operating system. They will transform in the format that is more suitable for the business analytics, and they will load it to your analytic database. What did it mean more practically speaking? A company might have an ERP on a CRM system where it gives all the information and it gives the current state of the company, what is going on, what is happening right now. And this data will have to be ingested to a system that will extract the data from the different system and will ensure that all this data will follow the same rule, formats rule, the dates will represent in the same way, addresses will follow the same structure, and the schema also will be denormalized in a way that will make more feasible to be analyzed. And finally, the data will be aggregated with the level of detail that was seen useful for the business needs. And this is important to understand that in this era, there was a lot of effort to make a long-term project to understand, okay, what are the data that we have, what are the business needs that we have right now, and how we can make a model that will fit the best use. And it was a long modeling work, a lot of work to understand exactly what was the requirement. And it was needed for many reasons. First of all, I think I want to highlight a technology point of view. At the time, we're talking in the 2000, 1 gigabyte of RAM of hard disk was more than $7,000. And if you talk even about memory, that was way more expensive. So we're talking about 800, closer to $1 million for 1 gigabyte of memory. So you can really understand why to reduce the granularity of your data, to try to synthesize only the things that you know you will make use of your data was a really important prerogative. This, of course, changed, and I think the big change was in around 2006, 2004. 2004 where was the year that the paper from Google about MapReduce model, so how to actually scale computational and different machine with a relatively simple programming model that is based on map function and redox function, start to be popular. In 2006, Yahoo then released Hadoop. That was the framework that was trying to implement what Google's paper was doing, and change a little bit the way we were managing data. This also was, but you also understand it was also a different change in the cost of the different technologies. Already we were just 6 years were passed by, and we have a dramatic drop in the cost of storage. We got to storage be 20 times cheaper than what it used to be. And also the price of the memory started to be 10 times cheaper. So I think this started to also to make possible to company. I think there was two things. One, the possibility company can finally start to store also high granularity unstructured data to the raw data in the original format, because they can. So there was a little bit the concept, just store all your data, even if you don't know how you're gonna use it, because maybe in the future you will. And there was also a new figure that was coming popular in company, at least in the big one, the idea that data scientists and machine learning will need to get to the original data to train, because you don't know how actually you will use this data before, and so you cannot make this work of preparing the data for a specific use, because you cannot predict how you're gonna use this data. So that's basically meant that you were trying to keep the data as closer to the original data. The stage then improved a little bit. So 2012, I think it was also a very pivotal year for the data infrastructure. I think that we had two main innovation coming. From one side, it was the year that Apache Spark was released. Again, here the technology change was the memory start to be also cheaper, so we can start to also make more focus on using memory to improve computation and have a better way to connecting storage and computation was not so more important. That will become less important than it used to be. probably even more important for the industry per se was also the growth of cloud columnar databases like Redshift, which basically meant, yes, you can have all the functionality of a traditional data warehouse on a traditional SQL database, but you can put it in the cloud and you can scale without having pain. So you can really start also to store high granularity data and a lot of data also in a MySQL database, in a SQL database, and you can still analyze it frequently. So I think those were already two main important change in the technology stack at the time. Because I think that led to what I think is still the current architecture in many companies, and still what we still predominant in the last years is an architecture that is basically divided in two different systems. From one side, we still have a process of extraction, transformation, and loading to get the data and put it in a data lake, which basically means an object storage where you can dump all your data. What is changed before? There's the transformation. The change in the format of the data now is very minimal. So we try to keep the data closer to the original source format, and to be able to accommodate feature change. This is done because in this way, machine learning and data scientist and engineer can get access to the original source of data, and they have more flexibility to when building their machine learning model or when trying different data scientist approach. But per se, this really didn't kill the data warehouse. Didn't kill it because there was still a need, and there's still a need to have a common model that it would be shared with all the people doing analysis, all the data analysts. They ensure that if they want to run a query and they want to understand how many sales we had the last year or last week, they will all come with the same question and they will not have to repeat all this work. So we basically got another extraction transformation process, and in this time the focus will be more on transformation, on a transformation that is business oriented. So trying to transform the data for the business needs that you have right now. And I think this is how we saw this current stage with central database, data lake, and what was this lakeshore mark data warehouse on the cloud that will serve analytics. So two systems to serve two different kind of users. I try to summarize a little bit the evolution of this technology in this slide. So I will move to data warehouse, data lake architecture, and what we're going now in this multi-modal cloud architecture. So again, to summarize, I think more or less what we said, what the changes in the beginning last 10 years, I think it was 10 years ago, it was the start that we really saw the cloud computing emerge. So if we say 2006-8 was the moment that we start to have the split of the architecture for machine learning and from business intelligence, from analyst. There was a moment that these two ecosystems split. 2012, 2015, more or less, was the years that this architecture start to move on the cloud, and we start to see most of the big players in these areas, meaning Databricks for the platform for the data scientist, Redshift, BigQuery, Snowflake for the cloud data warehouse for the data analyst. And then we got to, I think, what is the more recent architecture, at least is the tendency that we are seeing nowadays, is I think the push from these two different stack technology to compete and to try to get into the others market. So for one side, I think that we saw data lakes providers that are trying to provide data warehouse analytics, so not serve only data scientists or machine learning, but also serve analysts. And I think this is most of the focus of Databricks is putting on with the new products they're releasing. Like this year has released the Databricks SQL endpoint that's promised to have a SQL way just to query every data that you have in your data lake. Dremio also has been pushing this area. On the other side, we have also database, analytical databases like Snowflake or BigQuery that they are trying to get into the area of machine learning, and also they're trying to get into the area of data scientists. So, for example, this was the example we saw with BigQuery releasing BigQuery ML. So the possibility to run machine learning directly on your SQL system, or with the recent release of Snowpark from Snowflake that will allow you to use Python or different programming languages just to query, analyze the data, which is one of the requirements usually the data scientist has, because always the different profiles also have grown to a different preferred way to access to the data. And I think what is one of the most interesting innovation in the last years, and I think both systems anyway are trying to converge, is this data lake table format. And I think this is where we saw, I think, the most interesting change in the industry in the recent year. What does it mean? Basically, object storage are really cheap to store large quantity of data, but they represent data as blobs of files. But when we want to analyze, we would like to see them as a collection, as a table, as something that we can relate and have a schema and a common way to analyze it. And there was a technology gap to make it possible. And this has been the focus on many frameworks like Apache Hudi, Apache Iceberg, and Delta Lake that they try to solve. I really like to speak a little bit more about this technology, how this gets into the practical scenario. When we put all this technology all together, then we end up to have a pretty complex scenario with a lot of pieces going on. But again, in this image, it can be distracting. I think it is important to see how the different tools integrate, and many things are still remain the same. We still have the source of the data. We still have one initial phase that is the ingestion and transformation. So we get this data and we transport this data in the system that we use for analytics, whether it's the data warehouse or the data lake. And finally, we can query this data and modeling this data and setting the right way to describe this data, so in a way that can be consumed by analytics and by BI and by application. The overall framework is and different tools are still the same. What it changes, of course, are exactly the technology that are being used. And again, I will say that the technology is split into different architecture. We see that from one side, we are companies that they prefer to then use the cloud data warehouse as a central foundation of their data platform. So either they decide to store all their data in Snowflake, or they decide to store their data in Google BigQuery, for example. Those company will focus on a stack that is more like this. Here you can see the difference in the color. Basically highlights the sector where has been more interest in the recent year. So where we're seeing more change. I think that's above all these things has been interesting to see. There's a lot of interest on the metrics layer. Metrics layers. It's basically a way to ensure that everybody in the company, when they want to get some KPI, want to measure something from your source of data, all of them have the same response. And this comes from something that might seem trivial, to be sure that if we want to aggregate by weeks, everybody in the company agrees that a week starts on Monday. And if you want to aggregate by Europe, everybody in the company agrees that Great Britain is a part of Europe or is not, depending on what is the policy. So this metric layer basically ensures this consistency in how we analyze data. Also, a lot of focus has been in reverse ETL, which basically means to get the data from your data warehouse and put it back in the sources. So to make operative results of what your analytic needs. And that is focused on a way that you can directly get the data and ingest in your CRM or ERP system. So this all the focus on how these things get integrated. I think that's another interesting topics is a focus that we've seen, especially with a lot of work on hacks on DeepNode is on data workspace. Data workspace are basically tools that allow data scientists to get access to data and to play around and to prepare application that allows them to play and get insights and be more interactive. I think this is an interesting trend, and also the result of having platforms that are getting more stable and more standardized. So it's easier to get access to the data and to play around. And I think this is interesting trend. On the other side, as I said, we have also the stage that is more on the multimodal. So instead of, in this case, companies might lean to store all the data in object storage, in using open formats and using open protocols, and using the same system both for machine learning and analytics. And usually here, then you see companies that they use Spark for making some the transformation of the data, using either the Databricks or Amazon EMR. There has been a rise of a SQL query engine, so the tool that allows you to get the data from the data lake and run SQL queries. And I think this is there's been a lot of innovation. We have Starburst, Presto, Trino, Hive, Dremio, and also Databricks releases recent Photon and SQL endpoint, trying to get in heavy into this area. And again, those are tools they're trying to make possible for data lakes to operate as a data warehouse. So this is why there is so much interest on it. And again, here also with a darker green, we can highlight the things that have been changed the most. And I think this is interesting to focus a little bit on the stack of the lakehouse. That's, I think, in my opinion, technology point of view, is what is being more interesting and change. Josephine, is worth it to describe what it is a data lake or a data lakehouse at the current stage. So again, we have this foundation layer, which is where you are storing your data, and this is usually a service on the cloud where you just can put and retrieve the data. The interface is relatively easy. You have a blob of bytes, and you just give a name to this blob of bytes, and then you can read this blob of bytes through a HTTP request. Then we have the formats. How you write the data inside this blob of byte, and then above all formats. I think there's then been a little bit of standardization in this area, where probably Parquet is the most common format, or C and Parquet are columnar data formats. And then we have Abro, that is more different one, is different way to serialize data that fits more streaming application. On top of it, I think this is the interesting part, is this data table formats that was the missing key. The missing part that was closing the gap between data warehouses and data lakes. Basically, let's say they're trying to close the gap from data that is stored as a collection of files to data seen as a table with a predefined schema and a standard way to query it. There were many challenges to do so, but one of those was to be sure that if there are many processes that are analyzing the data or writing in a collection of data at the same time, we will make sure that this data will be kept consistent, and everybody will agree if the changes were needed or were done or not. There's a lot of technical details here, a lot of problems of distributed systems and how to make sure that changes will get propagated and everybody is aware of this change. And I think this has been an interesting area of the industry. I will give a little bit more details just to give an example and make easier to understand sometimes what it is, and will not get too much in details. Delta Lake is one of the more prominent technology to set up this data lake format. Again, what we saw is usually data in a data lake are organized as a collection of files. Those, for example, are Parquet files with some random names. What practically data lakes means is also to combine data with also a ledger that allows to describe exactly which is the status of the data, what has been added and changed in this data, and being sure that these changes are atomic, meaning that either they succeed or they don't, but it is something either or the others. And in this way, every concurrent operation sees consistent state. And under with this very relatively technique, these files are the description of the different changes. They goes with an incremental numbers, and each of the processes that try to read in this format, they have to compete to get the next number to file. And if they try to write the file that's been written already, they shall fail, because it means that something has changed in the data, and they need to know what has changed before they make an operation to be sure that this change is legit. I mean, this is really important because it's a small detail, technical detail, but it really is what is kind of trying to close this gap between what was the business world, the data analyst world, and the data scientist world. I need a little bit of advertising. I say that as an Incubist, as a company, we work in this area. As I said, we have a little bit bias in this direction. What we have is a way to enhance all the different data formats they are out there, and not only providing the assets property, so the consistency property that the others tools have, but also allows way to minimize the data that needs to be read to make analytics. So, in a few words, make sure that you get only the data that you need, but also you can do analytics, approximate analytics. That is, I think, is an interesting new open an application. So we know only way to manage the growth of the data. The project is open source, so you're welcome to check in our GitHub and have a try, and it's free to use. I will not say more because then it will be more advertising, but just to give an idea. To focus also, I think this is interesting to still talk a few words about the current stack for AI and machine learning. We still have, even though there is a tendency with the data lakehouse to try to join this system, so we see that many of these things can be run on the same architecture. For example, you might still do data science and machine learning on Spark, on Databricks, on EMR, and still you'll have the same data in the same data lake. There is still a bit explosion of different tools and different technology that try to solve a specific problem. Above all the things that are being changing, there are so many tools that are needed for ensuring quality and auditing. So a lot of work on validation of the data models. The more we have data model used in to make decisions that are important for our life, validating and auditing what is happening in this model is really important. There is a lot of interest and hype, I think also justified hype, I would say, on pre-trained models. So the ability to use models that have been already trained on, for example, natural languages, and so don't leverage the the investment, the computational investment and research investment of different hundreds of dozens of millions in machines and a researcher to build this NLP model and fine tuning for the specific needs. And I think that is a lot of interest work, for example, in Hugging Face to provide these tools for making use in different products. There's also, of course, the alternative solution just to provide some machine learning APIs. And I think that we saw many interesting use cases, many kind of sometimes frightening application that you can do with OpenAI, generating text that looks like being written by a human, or with new advances, even being able to generate images just by writing a description. This, of course, really interesting. Yet to be seen how this can be applied in application that's actually deliver value and solve after a problem of company. So this is always something that takes more time to be solved. Of all the things, I think that's is also interesting to highlight these two things. One is always the interest for low-code machine learning that's always been promised out there. There are always some limits, but I see there's a lot of interest in doing that. That probably is a way to reduce the barrier and to get like Pareto improvement. So many easy use case where we can use probably a simple model, not deep learning, not reinforcement learning, but a simple machine learning model and apply more often. But also we saw like interesting area of research, at least, is vector databases. Vector databases are databases that are used to serve machine learning model and to make sure that, for example, we can find similar images, because we are representing these images in a format that is how the machine learning understands it, like a vector, and we can find similarity. So those databases are kind of new way to store and index data to make sure that we find information that's on complex and data like text, images, music, and so on. I think this is an interesting area. So this basically finished the part about what was the history of the data infrastructure and what is the current technology. And then I would like to go in what I think they are going to be the problems ahead, the new challenges. But also I think this is a very good moment for you if you have any question and if you want to discuss any specific detail on the current and past stage of the data infrastructure. If not, I will continue. I don't know if Marco or there's anybody with a question. In the meantime, I will drink a little bit of water.
Yes, we have one question. So, in your opinion and in your experience, when you develop an AI project, how much of the effort are dedicated to the data part, and how much is for the AIs? If you can do some comment about that.
Yeah, that's a very good question. I think that I don't really have experience here, but I think that I recently heard talks from NDUNG, and I think it was explaining how we should be focusing on data more than models. And I think there have been for a lot of times focus on creating more complex model and having the machine learning model and the AI algorithm the more advanced. Whilst I think that is a common understanding right now, that's really the problem is not the model. Modern machine learning AI are getting like a commodity. As I said, you have system like OpenAI or you have Hugging Face that you can just pick the model that you want. What it is really important is that your data is in a good quality, your data is well described, your data is well updated, well maintained. I think so. There is a lot of effort to really focus on the data right now more than the model itself. So coming back to the question, I think that's investing in the data preparation, investing on the data is probably the smart investment right now. We still focus more about making sure that the data is in a good shape and quality, more than finding or trying to reinvent a fantastic model. Also, because probably the models are changing so fast, that's probably we get a new version of a new things, a new transformer, a new technique that can be applied, and models can be just changed, interchanged, but the data still remain the same.
Okay, thank you, Hi. We have another question. How could we govern the machine learning and AI and keep a track of different projects in different technologies? Are there any specific tool for that?
So there are, yeah. So this of course is one of the area in which there's been a lot of investment and a lot of interest. I think going back to this image is a very good way to see what are the different ways. So, for example, for experimental tracking, we have a solution like MLflow that allows you to make sure that's how you understand how these experiments are changing. There are many companies like Databricks that are also trying to focus on providing a framework that basically always the time that this ML operation is focusing on trying to get the data. Once you get the data, and also to train this data, get the feedback, put in production, and improve the loop and close it back. I think that it's safe to say that there are a lot of companies and a lot of projects that are trying to solve it, and they are trying to work on these things. I don't think right now we still have one common solution. So I think this is a little bit earlier. It's not, as I said, if in the data architecture we have some generic pattern to come out, as I said, there are a data warehouse or a data lake. In this part, I think it is still an open field. And that is as far as I can see.
Okay, thank you. But by the time we don't have more questions, if the audience has more, we can do it at the end. So please, Cesare, you can continue.
Fantastic, thank you. Okay, so going back to beyond technical limits. So I think that's for up to now we're talking a lot about the technological development of data, but I think they still like to understand there's technology is not the only reason why we don't take full benefits of the data, and we have many friction to get the data, to make good benefit of the data, to make good use of the data, and above all, I think it's interesting to see what are the new tendencies that they focus on two different main problems, which also, in my point of view, they share some common solutions, some common concern. So from one side, we have the organizational limits. Companies and organizations are struggling to get value out of data. Sometimes this is done for a kind of a disalignment between who knows about the data, who understand the data, who can take benefit of the data, and who has the duty to make sure the data is kept in good shape and maintain a good shape. This is also some limits on organizational. So we have centralized teams for doing the data platform, and how many information these teams have to manage, all this cognitive load. And I think in this area is interesting, and what I will describe later, the concept of data mesh. That's for people that are maybe familiar with the idea of microservices, which was the idea that you have a monolithic application, you try to divide it according to the different domain of the company. So everybody that's working in a specific area of the company will have to manage your service and have more ownership of what they're doing. Data mesh, in a very approximated way, try to do the same with the data. So in a way that every domain manages its own system, it is a way to reduce the distance from the data and the cognitive overload and the bottlenecks on our organization. But this is because there is complexity to get use of this data, and this is also something that is happening in a more wider scenario in Europe. There's a lot of focus on how Europe is probably missing out in a way to make benefit of the data, and how data economy is being promises to be the new wave in Europe, but somehow we are missing out. There are some friction that we can solve. and I would like you to say a few words about that. So first of all, companies are struggling right now with data. There are many statistics and way to describe it. I think that's the best way to understand is to understand the stress and the kind of complexity right now to be a data engineer in this industry right now. I always like the statistic: 78% of data engineers wish their job come with a therapist, meaning that they are so stressed, they are so much overloaded that they start to actually have mental issues. And this also relate to a very low retention rate on data engineers. So 70% of the engineers are likely to change, and this makes also a problem for company to get to retain this talent and to find the data engineers to implement the data initiative that they might have. And I think the interesting part of the data mesh is a way to change the way we organize the work, and we organize how we see the data organization in companies in a way that's to solve this part. I think that's when Zamak presented this concept in 2018. She defined 4 main objective of this architecture. I will not get super in detail, but I think that's the most important parts are this concept of the domain oriented. So this is more traditional in the data warehouse architecture, as again that you have to centralize all your data in one common schema, one common way to represent all your data, so much that everybody agree on this single source of truth, and everybody can get consistent data. Because getting consistent result on the data, of course, is still a priority, but still forces a lot of effort on this centralized data team that have to enforce this technology. And this, of course, also make a kind of a disalignment, because then you might have a company that's already using microservices, so you have different teams generating data when operating their operation, but this data is given to another team, and this is the other team that is required to make a use of this data in a business level. So this kind of disalignment, it's one of the things that the data mesh try to solve. The second thing I think is important to this is always maybe sometimes harder to put in practice, or to put in practical terms, but start to have data as a product mentality. When this meant basically that for each domain, we should define some profiles that have the goal to create products. And here I think considering that data is a product, data is something that can be used to provide some services, can be consumed by different entities of the organization, and who is responsible for this product should be try to make sure that everybody likes this product, loves this product. And I think it was a good way to differentiate. I know it's just wording, but sometimes it's interesting to see the change. Before considering data as an asset, and if you think about asset, you think about money, you think about gold. So asset is something that you try to keep by yourself and not share with anybody, because this is something precious for you. So you just want to share with somebody only if you really trust it, because to get something in exchange. What defining data as a product is really give to companies and to people in this company actually benefit and positive feedback to share the data to others. So meaning that if somebody in this organization, the more people use their data, the more they get bonuses, the more get feedback, the more recognition of the good work they are doing. The third point is a self-serve data infrastructure as a platform. I think this point was something that was confusing at the beginning, because I was reading as self-serving instead of self-serve, which is different. So yeah, of course, you want a data infrastructure that people can manually serve themselves, but you also want data infrastructure that will serve this data product to third parties, to products, to other services in an automated way. I think this is where we also see a little bit of a change to this. Again, going back to the original time we split between the operational systems and to the analytical systems. Here we are trying to do something different. Instead of splitting by operational analytics, to split in domain. And this domain, basically you have to manage both the operational and the analytics, and both of them they'll be served on a similar platform. I will do more example on this to explain better what I mean. And the last point, it's of course one major concern that's my opinion is, okay, then we have more domain, we are getting back to having data silos. So data that is unstructured, is full of different rules, different formats, and it gets more friction to access this data. So I think that is to counterbalance this possible problem. There is a new need to have a federated computational governance. So a common way to define how the data should be look like, how we should access the data, which are the service level objective, what I can expect with this data, what is the quality that I can expect of this data, and what I should be know about this data. And again, this is something that we see is also important in the concept of a more European ecosystem. Here, I like this example from the data mesh book, and also from the article they do. In this case, we're trying to think about one company that will be, we can imagine Spotify, but focusing more on podcast, and we can imagine this company to be organized in 4 main domain, and you can see this point. These are balloon are basically the different kind of interfaces of this domain to the external world. And what I think is interesting that you can see is that we have both operative endpoints. So literally to onboard a new artist, pay a new artist, or create a new podcast. So these are interfaces for now open world. That would be what would be a more traditional microservice approach. But from the same domain, we also get data products. So collection of information that's export the information from this domain to other domains of third parties. So in this case, we can see how from the domain of users, we can get the user updates, and these user updates can be used to generate podcast demographic. For example, I think we can see a little bit better how this attribute will define. And again, we are mixing here somehow the services, the microservices that the company already have. So we have a podcast service, we have artist onboarding service, and now this data then is combined into the creation of one product. And what is basically then is that what we see before all this process of extraction transformation is still exists, but is kept inside this domain, is make like not visible for everybody, and each domain basically manage this part of getting the data from maybe the user profile updates and joining and integrating with this data with the information that they have about the podcast. This, of course, is just to highlight that this works. This data mesh encompasses many different, I think, many different concepts. I think it's an interesting way to see how the way you organize the organization also affect the technology stack, and that doesn't need to be always the other way around. Instead, I think that's, especially if you go in the historical point of view, we saw that many times it was the technology that was pushing the change in the data architecture. But I think that sometimes, especially in the moment right now, that is, yes, there are technology problems, but there's also a lot of complexity that we have to manage. And in this case, a more human pushed shift more than a technology one. And so to try to embrace this distributed data architecture more for a problem to be to reduce the complexity, the cognitive load of all the people that's managing the information. One key part of Windows data mesh is the concept of distributed. And this is, I say, because it's distributed, because it's also important for the European data economy, meaning that you have the data distributed in different teams, and these teams can be different domains, but you can also make these data products across the boundaries eventually of the same organization and be shared with third-party partners and other companies. And I think this is especially important because this is part of the highlights of the goal that the European data strategy is trying to focus. These documents, of course, are sometimes it's relatively hard to see how these highlights strategy and idea can actually be put in practice and actually they're trying to solve. But of course, we can see there is a big push from Europe in this direction. We had the European Strategy Act in 2020, the Data Governance Act, also in 2020, that was basically trying to reduce some of the limits of sharing data between sectors and members of the state. We have the Data Act now that is trying to define how we can actually create value. So it is also an important part. If we can share data, but what we can do with this data, what is legal, not illegal, what is the framework, which is the legal framework to act. And also the forthcoming Digital Market Act that will focus on trying to break some of the barriers in entry to the data economy, because there are some monopolistic players that make very hard to get in. So that's, I think, is also interesting to understand the focus. Above all of that, as Cubist, we are a partner of the International Data Space Association. This association tries to understand how we can open the data, make a benefit of the data in a more open economy, making sure that everybody can get different sector can get benefit, and we really can create a new value on this economy. This, of course, is basically means to enable platform to be interoperable and enable to access to the data, but while keeping some important rules and ensuring some legal compliance that is really important for Europe. So this is why there is a lot of focus on data sovereignty, meaning that you can share the data with third parties, but the data should never get out of your legal ecosystem. So if you have the data in a specific country, this country has specific legislation, even if you want to give access to third parties, you should give access to this party without having to move the data. So there's a lot of work on common interfaces. And again, we are getting back to what we were talking before, a generic computational governance to access to this data, to make possible to use this data, maybe without moving the data, but moving maybe the computation to the data. This focus on protocols and make sure that there are open rules to access the data and move the computation is also one of the other goals, is a data level playing field. So make sure that new entrants, they can come to this industry, don't have impossible barrier to overcome. And I think this is also, again, this focus both from the international data space, from the data mesh, to have the idea of this decentralized architecture. So try to forget about to have all the system in a single data center, in a single system, because this doesn't respect the reality of how organizations, especially multinational companies, they have different departments, different teams, and they might serve different markets, but also for legal and privacy concern, that the data should not be moving. I think that's everybody heard about the recent problem with Google Analytics, and because it was moving data in the United States when they were not required to, and also the concern about Facebook for similar reason. And again, this private governance is basically make sure that everybody interest is represented in this architecture. And I think is a little bit of more provocation. I say that somehow it looks like you're trying to build a extra organization data mesh, so trying to leverage some of the same ideas, but more international. So make sure that we have, again, I think it's important to think as a major focus on data, data as a product, data as a way that can enable value, can also be seen a way to enable this data economy in Europe. And of course, this is also necessary to make sure that we have an infrastructure that allows it to do it. Before to conclude, a few things I think I'm gonna, if I may say, a few takeaways of all this presentation, then we can have more questions. I think that's major trends that I think is interesting are this concept of self-serve. Again, we saw it in many ways with the new focus on reverse ETL, we focus on the multimodal cloud. I think that's, and also the data mesh per se. I think that's the time where we have a totally different system for analytics from machine learning and a totally different system from operation to create a data-driven product. So to put machine learning model in production, this distinction is going to fade away, and these systems need to be more integrated. This doesn't mean that we have a single database for operational and transactional. This doesn't mean that we have this single system, or doesn't need to be, but it needs to be that the data that we can produce, this data product, need to be easy to be feed in operational system. And I think this is an interesting part, and also what we like to focus on could be data sharing with either within this in organization of outside organization is going to be also a key important aspect in the next year. I think something that we really would like to see what is happening. Again, here I think that there's always two things. One is to make sure that everybody agrees on the common rules, the common playing around, and again, to see this is the main concern in the data mesh, and it is the same concern in Europe. So I think this is really interesting to see what will come out. And from a technology point of view, I always do highlight that a distributed system only works if the technology can sustain it. And so to be sure that we reduce the data that needs to be moved, or we make sure that computation gets closer to the data, this is going to be a major change in the way we see set up data infrastructure, and this is something that this thing is going to be interesting to see and how to change. And in general, I think that the data infrastructure should start to be more simple and easier to understand. Sometimes there's many tools, many keywords, many buzzwords, and there is really a need to have a simplified solution because sometimes really you just need a tool to build a foundation. You don't have to have the latest flags. And I think this is basically an outcry. I really would like to have a better, easier understanding of what tools is the best, and don't require to have a PhD or to spend years in this industry to understand exactly what you need for. That's, I guess, that is the complex part, but I really hope that this industry will get closer to this area. And with that, I think that ends my presentation. If you have any question, I think it was faster than I thought.
Thank you, Cesare. We have some questions from the audience. First, is there any specificity to take into account when managing molecular structures?
Molecular structures. I don't think I understand. Can you read again the question, or maybe I?
Yeah, because Esther, you can give us more detail, because the question is there any specificity to take into account when managing molecular structures? Maybe it's a very specific question about one.
It can be. So yeah, I will try to understand what. So molecular. I think this may be related to what we're talking about with the vector databases, and this is basically what reminds me. So again, if you're talking about molecular, like the molecule in it's either proteins on protein folding and stuff like this, there's the complexity usually is the high dimension of the data and how to store this data. I think that's the only things I saw that is maybe interesting, and there is some kind of focus on that is on vector databases, because a vector database can basically, yeah, you get this molecular, you can encode it in some vector in a vector space, and then you can use a vector database to help you to find this information. And I just read that there's some research there. It can be interesting, but without the foundation information, I will not say much more.
The next question, we often hear about the data democratization. What do you think is still relevant? What is missing?
Yeah, so there's always, I mean, this data democratization is an interesting question, because data democratization has been the slogan for many companies, and from sometimes they were company because they were trying to solve new problems. With many companies, they were trying to solve, for example, automatic machine learning or automatic setup of rules, automatic tools of visualization. But I stand with another kind of opinion. That's, again, it goes more on this simplification of the stack. We need to have data platforms somehow to be boring, meaning that they can people can really understand easily what they do. They don't need to have a specific presentation. They can see this is the tool. Let's fix one simple specific needs, and it's really to understand. No, in this way, data democratization somehow really fits the idea to finally provide some framework that people can easily use. And I think that's the data infrastructure are getting there in somehow. So right now with this data multimodal cloud, you are getting easier approach. So right now is to set up a Snowflake or BigQuery to all your data. It's relatively easy to set up a data lakehouse. It's relatively easy. This is really getting closer to data democratization, at least for the BI part and from the data scientist part. What is not true for that is yet in the machine learning and the more advanced deep learning. This is an open field, and there I think that there's still a lot to do, and a lot of things to make it easier to understand, a lot of hype to fade out and wear out, so we can actually understand what really is needed and what it really brings value.
Sorry, we have more questions. How do you think the chip shortage is going to affect the data industry?
Yeah, this is a really relevant question to the current stage of technology. Is also that the manufacturing industry is being heavily affected by the lack of chips, and so this is why the cost of machines is getting higher. At the moment, the data industry is still still managing not to. Well, two things. First of all, if you see about the drop in the cost and reduction, as I said, we have 20 years ago when we passed through the 2006, we had maybe 22 times drop in price of disk. And now we are getting something similar for storage, but not more for memory. The RAM prices are they're not getting so much cheaper anymore. And also the processors are not getting so much cheaper anymore. So on one side means that computation is not getting cheaper. So we really have to be smart now to use computation. This is also why we see a lot more of emergence of this aggregated architecture, where you store the data in some service and you just use all the machine that you need at demand. This is something that's, of course, this lack of chips if pushing. So be more efficient in a way, use the computation. And the second thing I think is really interesting is also to see that this also in other ways pushing for a renaissance in the chip hardware industry. So I think that after many years that we've always been using the same architecture, now we not only have GPUs, we have FPGAs, we have a tensor processor, but we finally have ARM processor getting into the data center. There is the European Process Initiative that is trying to create a new European processor based on RISC-V architecture. So I think there is really a new opening on different architecture, and will be really interesting to see how the data tools that we have will adapt to make full benefits on all these different technologies. That I think will be really interesting to see in the future years. As a researcher, it would be interesting. What I really hope that we do it in a way that we keep the data in an open format and open protocol, so we don't have to cry out on integrating many things.
Thanks, Cesare. We have another question. Do you recommend to develop a strategy for increased data sharing inside companies?
Yes, I think this is a really good question, and probably above all the tools, the most important part is to develop some KPIs that can allow people to really measure how the data is shared, and to give positive feedback of the people that are responsible to share this data. And I think this, if you read the book from that, from Zamak, I think this is really interesting. That sometimes the tricks can be relatively easy. So you can provide on your data sharing platform some questionnaire. So you calculate the net promoter score to understand if the consumer of your data are happy or not. So this doesn't need to be something advanced, can be something just some feedback to understand how the people are using, and to also provide some kind of internal loop. And I think it's really important that there is already in place some kind of benefit. So people do this because then they will get recognition, they will get maybe salary increase, or they will have some kind of benefit. And I think this is the most important part, to get that now company can put it in place right away. How to do in technology, I think this is the part that is missing. There is no data mesh platform right away, and the company that's already implemented have had to implement it themselves. These are analysts will see something coming on in the next years. But again, the first things company can do is put benefits and recognize this effort.
Okay, thank you very much, Cesare, for this talk. We should remember to our audience that all this masterclass will be available in the CDI's YouTube channel. So you in the following days you will receive this masterclass and a short survey to improve our masterclass. So, at the name of Sidai, Cesare, thank you very much for this ponent, and to all our audience. We will see you in the next masterclass. Thank you a lot. See you soon.
Thank you to you. Have a great day.